Alright, the next example that I want to take is question number 6. Okay, you see that in question number 6 you have 3 minus x over 3x squared minus 2x minus 1. Okay, and this is indefinite integral, meaning that there is no limits of integration. Okay, so the idea here is, so try to get the factors of the denominator. So I want to do without the integral, and I'll put the integral sign at the end. Okay, so what are the factors of 3x squared minus 2x minus 1? So you can write 3x squared minus 2x minus 1 can be written as 3x squared and then minus 1, because we need two numbers whose product is 3. Product equals to 3, and then sum equals to -2. That will be -3 and 1, right? Product is -3. Product is 3 times -1 is -3. Product is -3 we need, and the sum needs to be -2. So you get at -3x plus x minus 1, and if you group the first two and the last two, you get 3x take out x minus 1 and then plus 1 x minus 1. So basically you get 3x plus 1 and then x minus 1 are the factors of the denominator. You see that? Therefore you can write 3 minus x divided by 3x squared minus 2x minus 1 equals to, now 3 minus x, you can write this as 3x plus 1 and then x minus 1. You can write it that way. You see that? So but with the partial fraction, this has the two different linear fractions in the denominator, right? Two different linear fractions in the denominator. So you can write a over 3x plus 1 and then plus b over x minus 1. You see that? So the rule number 1 applies, meaning that what we do here is, because they were non-repeated linear factors or the different linear factors, then we can write that as a over the first factor, right? And then b over the second factor. Okay, so what I'm going to do is I want to copy that 3 minus x over 3x plus 1 and then x minus 1 is another parenthesis, right? Equals to, what do you write here? You try to write the same denominator, 3x plus 1 times x minus 1, right? And then you do 8, it's just the cross multiplication, right? And then this with that one, so 8 times x minus 1 plus b times 3x plus 1. That's what you're going to write, right? Now if you multiply the both side by that factor in the denominator, you will cancel out that, right? So what is left then? What is left is 3 minus x is equals to a times x minus 1, and then plus b times 3x plus 1, right? As we did the previous example, like example number 1. Now what are the values of x we should take? Is you decide, you pick the value of x that makes at least one of the factors 0. So what I want to do is I want to pick x equals to 1. That will make this 0, right? So you'll get 3 minus 1 is 2 equals to 0 plus 4b. That's what you get, right? Because 3 times 1 plus 1 is 4 and then b, right? So what is b then? B is 2 over 4, that is 1/2. So we found the value of b. So what should be the next value of x we need to plug so that another factor is 0? You need to plug x equals to -1/3, right? Set x equals to -1/3. This implies 3 minus 1/3 equals to, this will be a times -1/3 minus 1. Oh, I plug in x equals to -1/3. So this will make this the left side positive, right? Because you see that if you plug there, you will get 3 plus 1/3. So what do you get on the left then? You get 3 times 3 is 9, because there is 1 in the denominator of that. So you'll get 9 plus 1, 10 over 3 is equals to a times, that will be -4 over 3, because there is 1 in the denominator, right? You just do the cross multiplication there again and then you add them. So now multiply both sides by 3. What do you get? You get that 3 and 3 cancel out, right? So a is what? A is -10 over 4. You see that? So a is -10 over 4. A is -10 over 4. That is -5/2. That is a. Okay, now what do you think then? So what is the partial fraction form? That will be, thus we get 3 minus x over 3x squared minus 2x minus 1. That can be written as a is negative 5 half over 3x plus 1, and then plus 1 half over x minus 1. That's what we got. Now it is easy to integrate, right? Because if you add the integration sign on both sides, if you add the integration sign on both sides, what do you get? There is dx, and then on this one also dx, on this one also dx. Now because our question has integral, right? So basically you take without the integration and then just find the partial fraction, find the simplified form of the sum or difference, okay? And then you use the integration at the end. Alright, now let us see what is the integral of this. You can basically find out, pull that negative 5 half out and then write 1 over 3x plus 1 dx, right? And then plus 1 half out and then 1 over x minus 1 dx. But do you know this formula? U prime over u dx is equals to natural log of u plus c, right? That's the formula, right? Because if there is a function in the denominator whose derivative is in the numerator, then this can be written as natural log of u plus c. Now there is a function in the denominator, but what is the derivative of 3x plus 1? It is 3, right? So I need 3 there. So what I'm going to do is I'm going to do 1/3 times 3 so that I can pull that 1/3 out. Okay, similarly here the derivative of x minus 1 is 1, so we are good on the first one. Okay, so what can we write there? The negative, so it will be negative 5 over 6, because 5 half times 1/3 is 5 over 6, and then you can write 3 over 3x plus 1 dx plus 1 half. It is already in that format, right? The derivative of the bottom is on the top, so you can write natural log of x minus 1, and then plus c. So I'll write that c, I can write that c later, 6, and the natural log of 3x plus 1 plus 1 half natural log of x minus 1, okay, plus c. That is the final answer. Okay guys, so if there is an integral sign, that's exactly the same way that that you do it. Okay, now so the next example I'm going to give you is that does not have the linear factor in the denominator. If there is a quadratic factor, then how do we do it? Okay, that is the next thing that I'm going to do. Okay, so what I want to do is I want to do question number 22. Question number 22 from the book. It has 1 through 5, and then x minus 1 divided by x squared times x plus 1. You see that one of the factor is quadratic here. So what you want to do, you can do ax plus b, or you can do 1 over x and then a over x, b over x squared, and then c over x plus 1. You can do either way, but what I'm going to do is I'm going to show you how to use the quadratic way. Okay, you see what I'm saying? I was saying that you can do like x minus 1 over x squared times x plus 1 is equals to, you can write a over x plus b over x squared plus c over x plus 1. You can do this way because this is repeated, but not all the time you get the repeated, so sometimes you get non-repeated way. Okay, so what I want to do is I'm assuming the another method. I'm doing the another method. Okay, so what I want to do here is x minus 1 over x squared times x plus 1, okay, is equals to, I want to write ax plus b over x squared plus c over x plus 1. This is like I'm treating this as a quadratic factor and this as a linear factor, not a repeated. I'm not treating as a repeated factor, so you can do either way for this one. But if there was like x squared plus 1, you should be doing this way, so you cannot do that way, repeated way. Okay, alright, so how do I simplify this then? So on the right side you can just write the common denominator, x squared times x plus 1, right? and then you just do the cross multiplication. What do you get there then? So you get ax plus b times x plus 1 plus c times x squared. That's what you get. Okay, and in the left side it is the same thing, x minus 1 over x squared times x plus 1. Now look at this. So you cancel the denominator because they are the same, right? So what do you get then? So what you got there is basically you got x minus 1 is equals to ax plus b times x plus 1, okay, and then plus c times x squared. Now we need to pick different values of x that makes one of the terms 0, right? So let me pick x equals to 0. Set x equals to 0. If I set x equals 0, what do I get? I get negative 1 equals to a times 0 will be, so b times 0 plus 1 is 1, so just b plus 0. So what do you get? This implies b equals negative 1. So we found the value of b already. Okay, so next I want to pick x equals to negative 1. Next I want to pick x equals to negative 1. Okay, x equals to negative 1. Why? Because I know that will make this factor 0, that whole thing will be 0 there. So if you do that, you will get on the left side negative 1 minus 1 is equals to a times negative 1 plus b is what? Negative 1, right? And then but the thing is x is 0, x is negative 1, so that will make it negative 1 plus 1, that will be 0, so whole thing will be 0, plus c times negative 1 square, right? So the whole thing is 0 because this guy is 0. So what do you get? C times negative 1 square is just c equals negative 2. C equals negative 2. I got c as well. Now what do I need to do is I need to get a, the value of a. So what do you want to plug in for value of a, to find out value of a? I don't want to plug in x equals 0 because I did that already. I don't want to plug in x equals negative 1. So what is the smaller number is better to plug in. So you can try any number because we don't get one of these factors 0 if you try other than these two. So I'm trying just a random number. So that number would be, let's say x equals to positive 1. What do you get? On the left side you will get 0 equals to x is positive 1, so it will be a times 1 plus, what is your b? Negative 1 times 1 plus 1 is 2 plus c times 1 square, right? So that will be how much? 0 equals to a minus 1 times 2 plus c. Oh, by the way, how much is c? I got c is equals to negative 2, right? Let me write down here negative 2 there. So that is negative 2. Okay, so you get so it will be basically this whole thing will be the negative there because negative 2 times 1 square. See that? 2 times 1 square. So minus 2 there. Okay, what do you get then? So 0 equals to twice a minus 2 minus 2. So twice a equals to 4. So a is equals to 2. So I got the value of a as well. So what will be the final answer then? I'm just plugging into here. Okay, you get therefore x minus 1 divided by x squared times x plus 1. This can be written as ax plus b. How much is a? Is 2 times x. B is what? B is minus 1. Okay, 2x minus 1 over x squared. Okay, and then what? Then plus c is how much? So minus c because c is negative 2. So minus 2 over x plus 1. Okay, so what we need to do is we need to find the integral of these because there is integral. Okay, and then find the limit also because we need to plug in the limit of integration and find the exact value there. Okay, so hence the integral 1 through 5 x minus 1 over x squared times x plus 1 dx can be written as integral of 1 through 5 to x minus 1 over x squared, right? And then what? And then minus 2 over x plus 1 and then dx. That's what I get. So I want to get the integral of each of the term there. So what I'm going to do here is I'm going to do like this. 2x over x squared. and then minus 1 over x squared minus 2 over x plus 1. But what you can do is you can do the integral for each of the term and then write dx there, right? Dx and then dx. So 1 through 5, 1 through 5, and 1 through 5. You see that? So what is this? You see that the derivative of the denominator is on the numerator, so it will be natural log of x squared minus, here it is, what is the integral of 1 over x squared? You can move this to the top, it will be x to the negative 2. So integral of x to the negative 2 will be x to the negative 2 plus 1 over negative 2 plus 1. So you will get negative 1 over x. So negative and negative will make it plus later. And then minus, what you get here, the derivative of the new denominator is 1. So you can write 2, and then what is left is 1 over x plus 1 integral. That will be natural log of x plus 1. Okay. Now, what are the limits of integration? 1 through 5. So what we do next is we will plug in that limit. So make sure that this is plus, okay, because that negative times negative will make it positive in the middle, right? So you get this one as positive. Now what I'm going to do, you can use calculator after that, okay? Here, if there is a limit of integration, but if there is no limit of integration, then you cannot use calculator there. So just plug in here. So plug in 5, you get what? Log of 25, natural log of 25 plus 1 over 5 minus 2 natural log of 6. Okay, that's when I plug in 5. Minus. Okay, minus, now plug in 1. What do you get? Natural log of 1 is 0, right? Natural log of 1 is 0. Plus 1 over 1 is just 1. And then, let me write a minus. And then the first one is 0 plus 1 and then minus 2 natural log of 2, right? That's what you get. By the way, this you don't need that parenthesis does not close. You can close, or you don't have to, basically. We get for the first term. So what do you get? So it is natural log of 25, right? And then natural log of 25 minus, you can write natural log of 36. Why? Because that 2, you can write that 2 as here on the exponent, right? And then minus minus plus natural log of 4, right? You see that? Because negative times negative will be positive. That 2 again you can write on the exponent of 2. Now what is left is plus 1/5 and then minus 1, that minus 1. Okay. Now use the properties of the log. You see that natural log of 25 minus natural log of 36 can be written as a single natural log 25 times 4 over 36, because if there is a plus, then that will be the product in the natural log, and if there is minus, it will be divided. And then plus, what is 1/5 minus 1? That will be minus 4/5. That's what you get, okay? Because 1/5 minus 5/5 is 1. So negative 4/5. So how much you get here is 25 times 4 is 100. Okay, you can do like 9. So you can do natural log of 25 over 9 minus 4 over 5. That is the final answer. Okay, so if there is the definite integral with the limit, exactly the same way, only at the end you will have to plug in the limit, integration with the limit, and find the integral and plug in the limit as we did before. Okay, so that was question number 22 from the book. That is question number 8 from the book. So question number 8 from the book, it has integral x cubed minus x plus 3 over x squared plus x minus 2, x squared plus x minus 2, and then dx. Okay, is this proper rational fraction? Is this proper means is the numerator degree is smaller than the denominator degree? No, it is improper, because the numerator function has bigger degree, higher degree than the denominator function. Okay, in that case we need to do long division and then write the remainder into the partial fraction format. Okay, that's the rule that we discussed. Okay, so let us divide the top by the bottom by the long division technique. X squared plus x minus 2 divides x cubed minus x plus 3. Okay guys, so how do I divide that? Is to divide this, you need to first divide the first term by the first term. That's what you need to do. Okay, so that means x cube over x square. What do you get? You get x, right? Write down that x here and then multiply this x to all of these terms. X times x square is x cubed, x times positive x is plus x square, x times negative 2 is negative 2x. Okay, and then now subtract this minus that, subtract that one. Okay, so this is just underlining, I was underlining that one, this and that one. Okay, when you subtract, you change the sign. That means subtract means that change the sign, that will change the sign, that will be change the sign, like that. Okay, so what do you get? You get x cube and x cube cancel out, so what is left is negative x square, and plus 2x minus x is plus x plus 3. You see that? Now divide the first term by the first term. What do you get? Negative x square divided by positive x square is negative 1. Write down that negative 1 here and multiply that negative 1 to all of these. So negative 1 times x is negative x square, negative 1 times x is negative x, and then negative 1 times negative 2 is positive 2 there. Did you see that? So basically what do you get then? So you got basically, let me see that. Now we are subtracting, right? Subtracting means changing the sign. So plus, plus, minus. So what is left at the end then? So it is, this will cancel out, x plus x, because that's the new sign. Okay, so x plus x is 2x, 3 minus 2 is plus 1. So that is the remainder. Okay, hence you can write like this. Hence, so the x cubed minus x plus 3 divided by x squared plus x minus 2 can be written as the quotient x minus 1 and then plus the remainder 2x plus 1 over x squared plus x minus 2. So you can write that way. How did I write that? Because you see that in the regular division, like if you are dividing, let's say 7 by 2, so it is 2 times 3 is 6, right? Subtract 6, so 1, remainder is 1. So you can write 7 divided 2 equals to quotient plus remainder over the divisor. That's the divisor. Okay, so what is 3 plus 1 half is 7 half, right? So 1 divided by 3, the quotient, plus remainder divided by the divisor. Okay, that's the division means. Okay, now that's what I'm doing. Now what I want to do is I want to just do x minus 1. Okay guys, so x minus 1 over, so over x minus 1 plus, I want to do the partial fraction for this. Okay, so in that case what I want to do is I want to write the partial fraction for that, means I want to write plus, and what are the factors of the denominator? 2x plus 1 over, what are the factors of the denominator? You get the factors are x and then x, right? So what do you want to write? We need two numbers whose sum is positive 1, product is negative 2, so that will be plus 2 minus 1. So that's the factor, right? That's what it is, x cubed minus x plus 3 over x squared plus x minus 2. So these are easy to integrate. So, but this is not very easy to integrate. So what I'm going to do here is basically, you know, actually for this problem you don't have to do like this too, because you see that when you integrate, the derivative of the denominator is in the numerator, so you can write natural log of that directly, no problem. You can write natural log of that directly. Okay, so without any problem there. You see what I'm saying? I was saying that if you integrate like this, and like that, integrate like this directly, then what would be the answer? It will be x squared over 2 minus x plus natural log of the denominator. You can write x squared plus x minus 2. Why? Because it happened to be, the derivative of the denominator happened to be the numerator function. If there is like u prime over u dx, then the integral is natural log of u. That is the formula. If you do the u substitution, that's what you get. If you get like set that equals to u, then that dx will be du. Okay, so you can do that way. Or, so the idea is not all the time you get similar problem, right? That's why in that case what you do is you need to take just this only. Okay, how do I do that? I want to take just this part and get the partial fraction for that, and then do at the end. So how do I do that then? So you get 2x plus 1 over x plus 2 and then x minus 1. That can be written as, what do you get? You get a over x plus 2 plus b over x minus 1. Now if you combine that on the left side, you get the same thing, 2x plus 1 over x plus 2 times x minus 1, right? And then equals to, what do you get? X plus 2 times x minus 1 there. So a times x minus 1 plus b times x plus 2, right? And then you cancel that denominator and the denominator. What is left there is basically 2x plus 1 is equals to a times x minus 1 plus b times x plus 2. Set x equals to 1. What do you get? 3, right? On the left side you get 3 equals to, this will be 0 plus 3b. So that will be 0 plus 3b. So what will be b then? B is 1 because you divide by 3 on both sides. Set x equals to negative 2. What do you get? If you set x equals to negative 2, you will get 2 times negative 2 is negative 4 plus 1 is negative 3 equals to a times negative 2 minus 1 and plus 0, right? So you get a equals to 1 basically, because negative 3 equals to negative 3a. So a is 1. So hence what you can write then? Then you can write hence you can write x cube minus x plus 3 over x squared plus x minus 2 is equals to x minus 1 plus, you can write 2x, that guy can be written as what? That guy can be written as a is 1, b is 1, 1 over x plus 2 plus 1 over x minus 1. That's what you got, right? B is 1, a is 1. So 1 over x plus 2 plus 1 over x minus 1. Now integrate on both sides. If you integrate on both sides, integrate. So what do you get? You get basically x squared minus x plus, what is the integral of this? Because the derivative of the denominator is on the numerator, because derivative of x plus 1 is 1. So it is natural log of x plus 2 and then plus natural log of x minus 1. So if you combine that, what do you get? X squared minus x plus natural log of, combining that will be x plus 2 times x minus 1, right? And then plus c. So if you get that, you will get exactly the same answer there. Okay. Oh, by the way, integral of x is x squared over 2. Okay. So you get x squared over 2 minus x plus natural log of x squared plus x and then minus 2. That's what you get if you simplify that, and then plus c. That is the final answer. Okay guys, so that's how you do if the numerator degree is bigger than the denominator degree. You need to do the long division, or even if the numerator degree is equal to the denominator degree, you do the exactly same method. Okay, you first divide, you will get a number as a quotient, okay, and then you follow the exactly same technique. Okay guys, so next I will present a couple more examples there. All right, thank you.